Welcome to part 7 of our Competency 17 practice. Welcome to part 8 of Competency 17 for our TExES exam. In this video, we will investigate problems that relate to the distribution of sample mean and involve the central limit theory. Before we begin looking at problems, there's a few things that we need to make a note of. First, the distribution of a sample mean. Well, the sample sizes must all be the same. And as we group all these samples, we realize that the mean value is the same as the population. Then we have the central limit theorem. As the sample size increases, the distribution of the sample means will approach normal distribution. This allows us to use the problems that we use. Instead of having to adjust from a small sample or small population to a large population, we can still use the same basic ideas with small adjustments. Okay, now I've devised a checklist rather that we can use. And for the large population, if the population is greater than 100, here are our formula options. If the population, capital N, is less than the 100, meaning, and these are over 30, they're considered large when they're over 30 data points. So, or say data on animals or people, whatever. So then notice that the mean formulas are the same. Now notice that your standard deviations are different. Okay, we will talk about this as we go along. And then we must have a consistent probability. And this requires that if you're like drawing cards, drawing things out of a bag, they must be replaced. And then we need to distinguish between if we're working with continuous data or discrete data. Okay, let's clear out some of these things we've got here. Okay, number 1. A university surveyed its students to indicate the number of hours of sleep per night needed per night. The results are normally distributed and show a mean of 6 hours with a standard deviation of an hour and a half. And our sample size is a random group of 100 students are selected from the survey. What is the probability that the sample mean will be less than 5.8? Okay, this is obviously continuous because they're giving us decimals, and hours have fractional hours from 1 hour, 1.5, so on. We know this. Okay. Now, and our sample is right at 100. Well, what do we need to do? Let's go back to our checklist. Okay. If it is 100 or less, we need to adjust our deviation to a sample deviation. So let's adjust that deviation. That means we need the 1.5 divided by the 100. In future, I will not write these out. I'll simply put them into the calculator. Okay, and I do not pre-calculate anything. Now, be wary that in some textbooks and some instructors pre-calculate, then enter it in. It can make a difference on this fourth decimal. Okay, you may see an issue with the fourth decimal. So it may vary up or down. All right, let's do this. Second bars 2. All right, our lower, okay, it says less than, so let's clear this out. So that means that we're going to put in our -1 second E 99. And if you don't remember what that is, look that up or look in my previous videos. I talk about it. what that is and why it's in the normal curve. So we're normally distributed in this situation, and that's one of the reasons we use the -1E99. Okay, our upper can be typed in as is. Okay, 5.8, double check that. Now, this is not our mean. Okay, our mean is actually just 6 and enter. And this is obviously not our standard deviation. We need to adjust 1.5 divide by second for the square root. And then we have 100, enter, enter, enter again. And there we go. That would be option D. Wonderful. Okay. Now let's go to number 2. Pull that up. If we have to, we can go back up to our checklist and need as it and take a look as is. Okay, number 2. The town of Centerville will be keeping statistics on its highest temperature, or they have been keeping each day for more than 200 years. Large population, a large population of data. That's a lot of data for 200 years. For the 200-year period, the high mean temperature has been 47.3 with a standard deviation of 3.6. If the random sample of 64 days is taken, what is the probability that the sample mean will exceed 48 degrees? Okay, we know this is continuous again because one big clue is we have partial degrees, okay? All right, so we know it's continuous. I'll write that in. We know that that's continuous. Okay, do we need to adjust? No. And note that it is exceeding. Okay. However, our our population sample is less than the 100. So we need to adjust. So we adjust our deviation. Adjusted deviation is 3.6 divided by the square root of 64. All right, let's put all that in. Remember, I do not pre-calculate anything. So second vars number 2, and it's exceeding. So I need to just put in the 48 as is because it's continuous. Now I need to use my 1 second E99. Enter. My mean is 47.3. Now, oh, let's see. Now I need to adjust 3.6 divided by second in my root, 64. Enter, enter, enter again. There we go. Looks like 5.99%. Oh, and we have that. C is our option. Okay, number 3. In a survey conducted with animal shelters, it is found that the mean number of cats in a shelter is 65. Okay, with a standard deviation of 9.6, a random sample of 40 shelters is selected. What is the probability that the mean number of cats in this sample will be less than 67? Okay, now you're going to say, well, that's continuous because I see that you have a deviation of 9.6. Not necessarily. We are not talking about the age of something. We are not talking about temperature that can go up and down. We are talking about individual cat shelters. It is an entity, and we get data from this one. We will go get data from another one. There is no information between one shelter to the next shelter. What's different with number two is think about shelter. Think about temperature. Difference in the shelter is a building. It stays there. This temperature is going to be going up and down. So when they say high temperature, well, think about that. It goes up, goes down, and a temperature in one part of a county or a city may be a little different from another part. Okay. So when we're using an animal or a place, if you think of it like that at all, then you know that it is discrete. Okay, the first time I saw this when I was younger, I really had a hard time with it. You get better as time goes on. Okay, now we have a sample, I didn't underline that, of 40 shelters. So we know that this is going to be a larger population. Let's see, a number of cat shelters is okay, because it says 65 and that's the mean. In for the number, let's see, it says found that the mean number of cats per shelter. So that's a group. So that means that's going to be a large group. Let's just put it that way. And we know that we will have to adjust. Why are we adjusting? Let's go back and look. Populations under 100. Well, we have an N population size of only 40. So I say it's going to have to be adjusted, and we are given the standard deviation, which sometimes is a clue. Okay, so let's go ahead and adjust. Okay, and we need our 40. Let's put that in the calculator and see how it comes out. Second vars 2. Okay, less than 67. Okay, and it's discrete. So we're going to have to adjust that number, but it's less. So we need our -1 second E99. Okay, now less than. So we are going to have to subtract out zero point 0.5. So we do not include our 67. So that's going to be minus the 0.5. Okay. So that will be 66.5. We had to adjust. Now our mean, they do give us a mean of 65. Enter. Now we have 9.6 divided by second. Okay, under the square root would be our 40. And enter again, enter again. Ooh, and let's see, we would have to round. Looks like our answer isn't rounded. Okay, why would that be? I can tell you why that would be. Here, look at it. We did not pre-calculate. If you pre-calculate this, it will cause this very last number to change. I told you, be wary of that. So A is actually our option. Before we move on, I want to say a little bit more about number 3. Okay, I made the statement that I do not right here, I do not pre-calculate. However, I need to show you what will happen. And I think that the test writers, they look into this before they select answers. So let's see, look at our or answer choices. Let's look at our answer choices. I've got two here that really concern me. I'll be honest, I just am not a fan. comparing this answer to this answer. Okay? Just something that you need to be aware of. And I see a typo there also. Here, let me move that. Okay, sorry. Actually, I could just delete that. Uh, just in time typo correction. Okay, like I was saying, I don't like this. Okay, so what is going on? Let's look at our calculator. If I go ahead and pre-calculate 9.6, divide that, okay, and then put my 40 in, that gives me a decimal that'll need to be rounded. When I put that into my calculator, I'm going to get a little bit of an error, a little bit of a adjustment situation. So let's do that. Okay, it depends on how I round this. Okay, as you see, our problem is already in our calculator. So we just enter, and that is where we had it put in already. And remember, we came up with this answer. And in my opinion, here, let me point this out. Choose green. That won't work either. Sorry. I don't like that 4. Okay? That should have been rounded. If you're looking at ours, it would be 0.8385. Not a fan. So let's go ahead and try it, and let's do a little rounding up here. Second, bars, 2, leave everything in. Let's go here, and let's round that. If you remember what we had on the screen before, 1.512. I believe will get us close. Let me look up there, because I can adjust this right at this point if I have to change anything. So 1.51. Oh, no, I was wrong. I need to make that a 252, and I can delete that out. Now let's see what happens. Oh, it does make a difference. Okay, so we may have, it's debatable between the two, but because the 4 was not rounded up, I'm going to say I don't like A, and let's go with D. And that's my reason why. It very well could be that what we need to do in this situation is get as close to a textbook answer as we can. And the sources that I have, where I looked it up, they use that rounded option. It's not my habit, not what I would do. Okay, moving on. Number 4. The mean source of a nationally administered test is 530 with a standard deviation of 80. If 20 sample scores are selected, what is the probability that the sample mean score will be between 520 and 550? Okay, let's get rid of all this stuff we were doing here. Okay, clear all that out. Okay, what do we have? Well, we have a discrete situation, so we know it's discrete. We have a deviation that we know is going to have to be adjusted. There's our sample size. There's our mean. And it's discrete, so this will also have to be adjusted. So we are adjusting everything that can be adjusted. Yes, okay, so let's move on. Let's go ahead and just put it in the calculator and see how we do. Second, bars. Okay, we are adjusting, so we need to have 519.5. We're doing minus a half, so we're taking off a half. And then we add on half to the 550, 550.5, enter, and we have a mean of 530, but we will need to adjust our deviation. So for our deviation, we have 80. So 80 divided by, and then underneath our square root, we put our 20, our sample size. Okay, enter, enter, enter again. And do we have, let's see, let's be wary of our options. Yes, in this case, they gave us one solid option, unlike number 3. And you can put in different ways. You can pre-calculate, go back and see what you get to see what the difference would be. Okay, now let's go to the next one. Number 5. Among 800 licensed drivers in the town of Slayton, it has been estimated that 32% of them listen to the radio while they are driving. A random sample of 50 drivers is selected using the normal distribution. What is the probability that exactly 18 of the drivers listen to the radio while driving? My opinion, that's probably 100%. But we'll go with what the problem says. Okay, it says exactly, and we have a large population. In this case, they gave us a percentage. Remember, it's mu equals population size times probability. Okay, so what are we going to put in the calculator? We're going to put in 0.32 times, okay, a sample size of 50, oh, no, times probability, excuse me. Probability sample size, all right. Probability and sample size, okay. Now, this means that, where's our standard deviation? Use, oh, okay. Did you notice? It says normal distribution, but there's no standard deviation. They gave us sample size. What does this mean? First off, people listening to radios, that's discrete. So we will have to adjust. Our adjustment is 17.5. Then add the 0.5 at the other end. Now, about that standard deviation. Look at it, the wording right here. Okay, normal distribution. This means that we do not need to do that adjustment. What we do is a calculation. So we are calculating, as it said prior, our sample size times our percentage times 1 minus the percentage. Now, if you need more information about this, I recommend that you watch other videos where they go in more detail about why this is. But there's a lot of clues here that help us figure this out. And one large clue is that they didn't give us the standard deviation. Now, let's put that in the calculator. Okay. All right. We have an adjusted size or adjusted normal distribution, our bounds. So we subtract 5 from the lower bound. And the upper bound, we add 0.5, 0.5 that is. And now our mean, we had to calculate that. So 0.32 times 50. Remember, I type in, I do not pre-calculate because it's easier to look at what you typed in versus going back and forth to figure out where you had incorrect calculations. 50 times 0.32 times 0.68, close my parentheses, enter, enter, enter again. Okay, do we have any takers? They've converted everything to a percentage. Okay, That means we have A. Notice I was looking around just in case we have anything super close, like the one issue we ran into. In this case, they gave us answer choices that were so deviated enough. They were far enough. See how number C, it's not even close. So that helps us out. Okay. Number 6. Among 800 licensed drivers from the town of Sladen, looks like they're using the same problem, but they're making changes. Okay. It has been estimated that 32% of them listen to the radio while they're driving. A random sample of 50 drivers is selected using the information from above. What is the probability that at least 20 of the drivers, this one was 18, now we have 20 of the drivers listen to the radio while driving? Well, everything is the same, all the adjustments except for the first adjustment. They're still discrete. So what are we going to use? Well, what we do is we use our -1E99 as our beginning bound, our lower bound, but our upper bound is, it says at, oh no, I am so wrong. At least, not at most. Oh, so we need to go the other direction. So we need to look at 19.5. For our adjustment, we are going to go below the 20. We are subtracting the 0.5. It becomes 19.5. Now, why? Well, let's think about this. We have our curve, and it's going to go over here, and it says, we have 20. They're saying at least. So what they mean is that, yeah, we need this whole area, including the 20. It's not saying greater than or above. Those words mean include the 20. Okay, let's put this in our calculator. So we have second bars 2. That means our lower bound is 19.5. Our upper bound is the 1 second to get our E99. And our mean is, oh, we had to calculate our mean, so we can just put in the same thing. Actually, I didn't have to get rid of that. Okay, now we still have the same calculated standard deviation. Enter. Okay. And looks like the only option in our multiple choice is C. That's even close, so it has to be C. Number 7. Among all married women in the United States, studies have shown that 65% of them have jobs outside the home. A random sample of 300 married women are selected. What is the probability that fewer than 220 of them have jobs outside the home? Okay, for this, it's discrete. That's the first thing. You're going to have to make your adjustments because you're talking about individual human beings. Okay, so that means that this number is adjusted. Let's see, it says fewer than. So we are not including the 220 in because of it's discrete. So we need 219.5 because we had to subtract 0.5. Okay. Also, let's see that we have to adjust, and we need to put in an adjusted mean. So that means we have our mu is 0.65 because they gave us a probability. They did not just straight give us the mean. And we multiply that percentage times our sample size. Let's see, do we need anything else? Yes. They do not give us a standard deviation. Not a problem. We can calculate our standard deviation. We take our 300 times our 65% times the rest of the percent. So 1 minus 0.65 is 0.35. So when you are calculating the standard deviation, make sure that your two decimals equal 1, just in case. Okay, so let's put that in. Second, bars 2. Okay, what is our lower? It says fewer. That means it's going to be at the end, the left end, the lower end of your normal distribution. So it's -1. Second, divide to get our E, then our 99. Okay, enter that. We have our upper discrete upper bound that has been changed. It is adjusted, make that adjustment. And then our mean. Okay, so it's our percentage times our sample size. Double check my numbers. Yes. And then we have an adjusted, or no, a calculated standard deviation, our sigma. So we have, I'm going to go ahead and push the buttons. You've noticed I push the buttons every single time. That's so you have a record every time I enter things. Say 0.65 times 0.35, okay? And that way, when you watch the video, you can see again and again what buttons I'm pushing. When you do it on your own, it's not necessary. I continue to enter until I get a calculation. So, am I even close? Okay, they change it to percentages, and I have 0.99. Well, there's only one option that's close, and that's option A, 99.85%. Okay, number 8. Among all the men in the United States, studies have shown that 22% of them enjoy playing badminton. A random sample of 150 men, okay, there's our percentage, are selected. What is the probability that between 30 and 40 of them enjoy playing badminton? Okay, we're talking about humans again. So this is discrete calculation. So we will have to make our adjustment. Remember, that's plus or minus 0.5. That's kind of a crazy comma there. Okay, we've adjusted that. And notice again, we do not have a standard deviation. Not a problem. We simply calculate that. Okay, what is our random sample? That's 150. And our percentage times our percentage. Then remember, times all the rest of the percentage, which is 1 minus the 22. And you know what? Let's shake it up a little. Why don't we just put that 1 minus 22 in the calculator? Because I pre-calculated that just by doing it in my head, and I've said it's not my habit. So maybe I shouldn't do it this time. Let's see what happens. Okay, standard bars. Okay, our lower is 29.5. Enter. Our upper is 40.5. And our mean, okay, we don't have a mean, so it has to be calculated. So let's clear this out. 0.22 times our sample size. Now, we have second. Okay. Now that standard deviation is 150. Okay. But let's use parentheses to do our multiplication. 0.22, close open. Now, I did that because I want to put in all the rest of the percentage, meaning 1 minus 2, 2. Close my parentheses and enter again, enter, and that did not work out well. Okay, looks like I made a standard silly boo-boo. Order of operations has been violated. Let me show you how I violated that. Okay, I've since corrected it out. So let's go back to that. Okay, I saw 40, 40. Okay, let's clear this out. What did I do that you should never do? Second, uh, under our square root. Okay, we need to always put multiplication. You can use your parentheses, but you must use your multiplication. So how I'm going to do it this time is I'm going to multiply like I did before and multiply. Then I will put in my parentheses 1 minus 0.22. Okay? If you do not want to pre-calculate, this is the way to do that. And I put in parentheses, not thinking, I knew better. This is the way to put it in. Okay, so if you have to, stop the screen and you can go back and look back at my steps to see where my mistake was. Okay, let's enter again. And this is what we should have. And with rounding, yes, that would be option B. Okay, number 9. A restaurant owner estimates that 85% of his patrons order complete meals. A random sample of 120 patrons is selected. What is the probability that exactly 100 of them order complete meals? Okay, this is discrete because it's individual people ordering individual meals. And these words exact clue me in. Remember, this is not a binom PDF. It is different, okay? We are using, our norm or normal distribution. So we have to stick within those parameters. So we have, here's our probability. That's our sample size, and we need to adjust. It says exact. That means we are adjusting below and above, positive, negative 0.5. So that's 99.5 and 100.5. I can do better than that here. It's not too much better, but it's there. Okay, let's try that on the calculator. Let's put all these things in. Second bars, 2. Okay, bottom end, lower bound. Okay, upper bound. Okay, now our mean, we must calculate that. 0.85 times sample size of 120. Now, we need to, I'm not going to use what's there. I'm not going to type over that. I want to go fresh. So we need our 120 times what is our 85.85 is our percentage. Now we need the rest times parentheses 1 minus 0.85. Notice when I'm doing that, I don't have to stop and think, what is 1 minus 85? It doesn't matter. And that will eliminate some errors like I made before. Do we have it? Yes, it is. Again, option A. Let's see. Yes, no, it is not A. It says, yeah, no, sorry, my eyeballs crossed. It is. Because B, that's the wrong. And this one is close, but absolutely not. It is far enough away, so it won't work. Okay, here we go. These will not work. And that's our last question in this video. Thank you so much for watching. And definitely thank you guys for putting up with the mistakes I made and letting me show you, how you correct these mistakes. And if you like my mistakes in my videos, please consider subscribing and maybe liking our videos and watch our next videos coming up. Thank you.